All right, these notes are about solving absolute value equations. So the first thing I want to start off with is just the definition of absolute value. This should not be the first time that you've seen it, but it might be the first time that we've actually written it down. So the absolute value of x literally means the distance of x to 0, which is something that we're going to keep in mind as we solve absolute value equations because it makes a difference for how you solve them and how you think about them as you solve them. So if we were starting with a problem, we're going to start super simple with some of our examples and we're going to make them more complex. So if we were starting with something like absolute value of n equals 9, then that means the distance of n to 0 was a distance of 9. So that means you have two options. You had n could equal positive 9, and then the distance from n to 0 was 9, or n could equal negative 9, and then its distance was 9. So two solutions. All right, example 2. We're going to make this a little bit more complicated. We're going to say 2n, absolute value of 2n equals 8. And so we're going to think of this. Now we're going to go ahead and kind of work through solving it. We're going to say basically whatever's inside the absolute value symbol could be positive or it could be negative. So this could have been the negative version of 2n, or it could have been the positive version of 2n. So the negative version of 2n has a distance of 8, or the positive version of 2n has a distance of 8 from 0. So now I'm going to say negative 2n equals 8, divide by negative 2, n equals negative 4, 2n equals 8 divided by 2, n equals 4. So it could be 2 times negative 4 is negative 8, and then negative 8 is a distance of 8 from 0, or it could be 2 times positive 4 is positive 8, 8 is a distance of 8 from 0. So it could be either of those answers. And then of course the problems are going to get more complicated from there. So the note that we have to make to ourselves here, and if you have a colored pen, I would maybe write it in color, or maybe put it in bold or whatever, is that whenever you're solving an absolute value equation, because of the way the absolute value works, you're always going to have a plus and a minus. Which typically means two answers. Because of the way 0 works, it's possible you could have one answer, but typically always two answers. And in our first two answers, we had the plus and the negative version of the same number, but as you'll see in this next example problem, that's not always the case. It depends on how the problem works out. So we're going to go ahead and do a problem with a coefficient in front of the absolute value sign. So I'm going to have a coefficient of 2. So this is not saying the distance of 2 times 3 plus r, or that this has a distance of 8 from 0. It's saying 2 times something has the distance of 8. So what we have to do first actually is divide that 2 over. So the way that you can do problems like this, do this type of solution method, is you can actually do order of operations backwards. This works whenever you're solving an equation. So if you're doing a sort of evaluation, you have a bunch of numbers and you want to see what they equal, you can do PEMDAS forwards. That's kind of like if you don't have a calculator and you just want to evaluate something, that's when you do the parentheses first, then the exponent, then the multiplication and division, then the addition and subtraction. But if you're trying to isolate a variable, you do order of operations backwards. So first, we would look to see if there's anything that we could get to add or subtract to get away from the variable. We cannot. There's a 3 here, but it's protected by the grouping symbols. So next we're going to see if there's anything we could multiply or divide to the other side to move it away from the variable. There's a 2 that's being multiplied, so we're going to divide by that 2. So we have 3 plus r equals 4. So this is the point where we say, okay, we have a plus and a minus version. This is where we do the two different versions of the equation. So we're going to do the negative version of the equation equals 4, and then the positive version of the equation equals 4. So I've got negative 3 minus r equals 4. I can go ahead and add the 3. Negative r equals positive 7. I'll go ahead and divide by a negative 1, and I get r equals negative 7. And then I'll go ahead and subtract the 3. R equals 1. So here we had two numbers, one positive and one negative, but they weren't the positive and negative version of the same number. They were two completely different numbers. It's not a bad idea to make sure that the numbers, if you plug them in, that they work. 3 plus negative 7 is negative 4. The absolute value of that is a positive 4. 2 times 4 is 8. Plug in a 1. 3 plus 1 is 4. 2 times 4 is 8. All right. Let's try another problem. We can make it, let's do one that's a little bit more complicated here. So we're going to go example 4. You have to be really careful when you do these problems. All right, so first we're going to look to see if there's anything that we can add or subtract over to the other side to get it away from the variable. There's a 1 here we could add, but it's protected by the grouping symbol, so we can't do that just yet. So next step, we're going to multiply or divide something to the other side. Again, just like the previous problem, we can divide by 2. So we have the absolute value of 2x minus 1 equals negative 34 divided by 2 is negative 17. And here we say that the distance of 2x minus 1 from 0 is a distance of a negative 17. That's not possible. You cannot have a negative distance. This right here is a negative distance. This is something you have to watch out for. Depending on what type of worksheet you're doing, this could be really common or not common at all. Depends on who your teacher is, who made the worksheet or activity. So this is actually no solution. There's no possible number that you could plug into an absolute value that could give you a negative output. There's just no way. An absolute value is never going to give you a negative output. So this is a no solution problem. Okay, I'm going to do just one more that actually has some complication to it as far as the steps go. This is example 5. All right, so negative 10 minus the absolute value of negative 2x plus 7. We're getting all the negatives in there to see. Equals negative 21. Now this one is, even though there's all these negatives in there, this is not a no solution problem. It's actually going to work out to do the whole thing. So we're going to go through all the steps. First, is there anything that you could add or subtract over to the other side to start getting the variable by itself? Yes, there is a negative 10 just hanging out right here. We can go ahead and add that to the other side. So now we've got the negative version of the absolute value equals negative 11. Next, is there something that we can multiply or divide to the other side to start getting the variable closer to being alone? Yes, there's a negative in the front, and I can go ahead and divide by that. I'm going to divide by negative 1. This is actually what works it out so that you can actually do the problem. So we have negative 2x plus 7 and the absolute value equals a positive answer. It almost looked like we couldn't do the problem, but because of that we can. at the moment when the absolute value is all by itself, that is when you can set up your two equations. So right here I have the absolute value of something equals 11. The distance of negative 2x plus 7 from 0 is a distance of 11. So this is where I can start writing my two equations. The negative version of the equation is a distance of 11. The positive version of the equation is a distance of 11. So I went ahead and I distributed my negative sign, positive 2x, negative 7. I'll go ahead and add the 7 over. 2x equals 18, divide by 2, x equals 9, subtract 7, negative 2x equals 4, divide by negative 2, x equals negative 2, and there are my two solutions. And I could go back and make sure that they work. Negative 18, so negative 2 times 9 is negative 18. Negative 18 plus 7 is negative 11. So negative 10 minus the absolute value of negative 11 is positive 11. Negative 10 minus 11 is negative 21. That's a negative 2, so negative 2 times negative 2 is 4. 4 plus 7 is 11. Negative 10 minus 11 is negative 21. So that solution works. And that is it for our notes.